Hello viewers, good day to you all. You're welcome to today's class. Remain your pro guide, Aisha Wenge. The video is sponsored by Proj Connect. Do not forget, kindly go to the Play Store, search for Proj Connect for you to get started, to get exciting and educative videos for undergraduate university students in all courses. So today we are going to look at a topic which is called combination. And remember, we started from factorial, we moved on to permutation. So today we will be looking at combination. Before we begin, I'd love to explain what we mean by combination, some of its real life applications, and then we'll solve some calculation questions and then give you an activity to solve as usual. Um, so before we begin, in permutation, simply focuses on order. Okay, so the arrangement has to be in order on the permutation. Combination focuses mainly on the chosen item, the items that are chosen. It doesn't focus on the order, that is the order of the chosen item. Just the chosen item, that's what combination basically focuses on. Combination can be defined simply as a mathematical concept that refers to the selection of items from a larger pool where the order of selection does not matter. Okay, so that's what combination is all about. Some of the real life application of combination is in scheduling and planning, lottery games, team formation, for example, in football, market research, resource allocation, DNA sequencing, card games, and a whole lot. So these are some of the few applications of combination in real life. So let's move on to the calculation aspect. But before we begin solving the questions, I would love to state the mathematical formula for combination. So combination is usually given as n combination r is equals to n factorial over n minus r factorial r factorial. So this is a mathematical formula for combination. The first question we have here says that a committee of 10 pro guides on Proj Connect app is to be formed from 12 men and 8 women. There's a condition. The condition now states that the committee must contain exactly 6 men and 4 women. So how many different ways can the committee be formed? So in a question like this, all we need to do first, bring out your parameters. Your parameters guides you on how to solve any given problem. So in this case, we have to solve the combination separate. We solve the combination for the men, then solve the combination for the women. When we get the two answers, we multiply them, and that gives us our final answer. So let's begin with solving for the men, the combination for men. So since it's a committee of 12 men, so it's going to be 12 combination, and the condition is that it has to be 6 men. So we have to check for 12 combination 6 first. That's for men, okay? So this is going, so here we have our n is equals to 12 and our r is equals to 6. So using the formula, it becomes n factorial, which is 12 factorial all over 12 minus 6 factorial, then 6 factorial. So here we're going to have 12 factorial all over 6 factorial, 6 factorial. We have discussed factorial in the previous classes before now. So this makes our work easier. And we know that here we're going to have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Then the first one here, 6 times 5 times 4 times 3 times 2 times 1 factorial multiplied by 6 times 5 times 4 times 3 times 2 times 1. So from here, this makes it easy. From this 6, 5, 4, 3, 2, 1 cancels out the whole of what we have here, right? So now let's simplify this. 6 here, 1, 6 here is 2. So the 2 we have here cancels out this 2. So this is gone. So we are left with 5 here 1, 5 here is 2, 2 here is 1, 2 here we have 2. So 2 here 1, 2 here 4, then 3 here 1, 3 here is 3. So at the end of the day, we are left with 11 times 3 times 4 times 7. And this gives us a value of 924. So what this means is that our 12 combination 6 is equals to 924. So now let's calculate for the women. Okay, the combination for the women, so from the question, is going to be 8 combination 4. So let's calculate for this. So here we have our n is equals to 8, r is equals to 4. This is equal to 8 factorial over 8 minus 4 factorial 4 factorial. So this is equals to 8 factorial over 4 factorial 4 factorial. Okay, so here we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 4 times 3 times 2 times 1. Okay, then this 4 factorial here becomes 4 times 3 times 2 times 1. So this cancels the whole of this, right? So we are left with here we have 4, 2 cancels out this 8, 3 here, 1, 3 here, 2. So we are left with 7 times 2 times 5, and this gives a value of 70. Okay, so we have the combination for women to be 70. So our 8 combination 4. So now we've gotten the combination for men and also combination for women. So all we need to do is to say 12 combination 6 times 8 combination 4. This is equal to 924 times 70, value of 64,680. So this is the final answer. So what it means is that the number of different ways that can be formed from this committee of to get for, a committee of 10 programs on Proj Connect app can be formed 4,680 times given the conditions from the question. So this is just as simple as that. Okay, so let's move on to the next question, which says that in a card game, you're dealt a hand of 5 cards from a standard deck of 52 cards. So what is the probability that all the 5 cards given to you are of the same suit? Okay, so let's solve this. Question even takes me back to one of the real life application of combination where I mentioned that it is used in card games. Okay, so this is one of the example. So let's bring out the parameters given from this question. So in a card game, you're dealt with a hand of 5 cards from a standard of 52 cards. There are 4 suits in a deck of ways to choose 5 cards out of 13. So that is going to be 13 combination 5. So this is going to be where n is equals to 13, r is equals to 5. So this is going to be 13 factorial all over 13 minus 5 factorial 5 factorial. Okay, so this is equal to 13 factorial over 8 factorial 5 factorial. So simplifying this, we're going to have 13 times 12 times 11 times 10 times 9 all over. So the remaining 8 downwards cancels out this factorial. So we are left with 5 times 4 times 3 times 2 times 1. So let's simplify this. 5 and 2 cancels out this 10. 3 here, we have 3 here. And this 4 cancels out 12 here. So we have 3. So we are left with 13 times 3 times 11 times 3, and this gives us a value of 1287. So the next thing we need to calculate now is that to choose 5 cards from all 4 suits is going to be 4 times 13 combination 5. So this is equals to 4 times, we have our answer for 13 combination 5 as 1287, and this gives us 5148. The next thing is for us to calculate the total number of ways to choose 5 cards from a deck of 52. Okay, so this is going to be 52 combination 5. So this is going to be 52 factorial all over 52 minus 5 factorial 5 factorial. So this is equals to 52 factorial all over 47 factorial 5 factorial. So when we solve this, we're going to have a value of 25,98,960. That's 2,598,960 ways. The last step is for us to now calculate the question, which is for us to calculate the probability of all the 5 cards out of the same suit. The probability is going to be the number of ways to choose 5 cards from all the 4 suits. We divide it by the value we got for the total number of ways to choose 5 cards from all the 52. So this is going to be 5148 will divide by 2,598,960, and this gives a value of 0.00198. And if we want to take the percentage of this, all we need to do is just to multiply by 100, and we're going to have a final value of 0.198%. So the probability of that all the 5 cards are of the same suit is 0.0198%. Okay, this is just as simple as that. So we have an activity which says that in a group of 10 students, 5,000 naira prizes will be given. How many ways can the prizes be distributed? So this is just an activity. You can try it out to keep you busy. If you have any question, kindly bring in your questions and we will take it up from there. I remain your pro guide Aisha Randy. The video is sponsored by Plush Connect. Thank you for watching once more. See you in my next class and bye for now.